Alright, hello guys. Today we're going to be looking at term-by-term differentiation and integration of power series. So the differentiation of power series using derivatives, it states that f of x, if the power series equals f of x, let me write this down. If this converges onto interval a minus c, a plus c, if it converges on this interval right here, then this term also converges on the open interval, minus c, a plus c, as well as a and x minus a minus 1. Yeah. So this is the differentiation of power series. It states that this theorem right here, if this converges on this interval, then this and this will also converge on the open interval. That is for differentiation. Now we can look at integration of power series. This part would be, this is differentiation. And then we're going to be looking at integration right here. So for integration, the same symbol right here, if this also converges on the open interval, then this term right here will also, this right here will also converge on the open interval, and see, this will also converge on the open interval. So you just have to know this for this theorem. So first we can look at the first example. We can okay, the question asks to determine the series obtained from term by term differentiation right here of the power series for, let me flip this page, for e to the x. F of x equals e to the x. So if we know, if you guys have taken Calc 2, we know that, if you recall, e to the x power is equal to the power series. Okay, now how to determine the series? Okay, so we have to take derivative of both sides of this. So if you take the derivative of both sides, dx of, I'm not going to write this thing down. So if we do that, we know that the derivative of e to the x is going to be e to the x, right? So we would have the same exact answer as before. Yeah, so this example is kind of simple because like there's not that much a different answer. So basically, to determine for e to the x power is just going to be this right here. Basically what we got in the original. Okay, now this one is going to be different. So for this one, we need to find, for this series, I'll write it down. g of x is equal to 1 over 1 plus x squared. No, it's 1 plus x. Right, like that. Find the interval of convergence. So, if we recall the binomial series, we know that this is going to equal 1 minus x plus x squared minus x cubed plus x to the 4 and so on. So now we have to take the derivative of both sides. So now if you take the derivative of d over dx, we're going to get 1 over 1 plus x to the power of 2. That's going to be this, and then we know that this is also equal to negative g of x. Yeah. So we now, if it's negative g of x, we know that we basically took the derivative of this function, right? We took the derivative of the function and we get this as the derivative of the function, which is negative g of x. So we know that this right here, negative f of x, is going to equal negative, or is equal to g of x. Oh yeah, I forgot the derivative symbol. Okay, so now g of x, if we know that g of x, then we can substitute this in, and we know that this right here in the function, the binomial series, x plus x squared minus x cubed x to the 4th, so on and so forth, is going to equal, we can get the negative sign, and then this 3 of x squared plus 4 of x cubed. We take the derivative of this and further simplify. This 2x, just basically get rid of the 0 and the negative. Now we get this, right here. We have to write this in the series notation. So this would be this is what we would get if you write it in the series notation right here. And now we have to determine the interval. So let's go into the, actually can we use, okay, let's use this part right here. To find the interval, we have to apply the ratio test. So the ratio test says that limit as n approaches infinity, the absolute value of 1 n plus 1 plus 2 n plus 1 all over 1 to the power n plus 1 n power, which is going to equal, we plugged in the n plus 1 x to the n power. This is equal to limit as n approaches infinity, n plus 2 n plus 1 absolute value of x, and this is just going to equal the absolute value of x. So now we know that this power series for x between the series converges for x between -1 and 1. So basically both of these series, we know that it converges. So the interval of the convergence is going to be -1 and 1. -1 and 1. That was for the differentiation power series. Now let's look at for integration. The integration is going to be different. So first, it asks us to find the power series representation of h of x equals ln of 1 plus x. Now, to find this, right, we have to first, we're going to have to use Taylor series for this, and calculating the derivative of h of x. So, as we take the Taylor series, get this, x. Now, we have to, integrate the first this 1 over x 1 over 1 plus x, we can we know that from here again, the equation, the binomial series right here, this is going to equal this, just like the other question, so on and so forth. And now we know that this ln of 1 plus x is equal to the Taylor series 1 plus x dx is equal to c plus x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4 and so forth. And when x is equal to 0, ln of 1 plus x is equal to ln of 1, which is equal to 0. So that means the constant c is going to become 0 as well, which states that ln of 1 plus x is equal to x minus x squared over 2 plus x cubed over 3 minus x to the 4th over 4. And if you write this into the series notation, you would get n over n. And this interval of convergence of this power series is going to be -1 and 1 with a bracket. So yeah, basically that's how you do it. Just basically for this, you just, instead of taking derivative, just take the integration, and you'll get the answers. This is like kind of like a theorem. It's not really gonna help you in math, I guess. Wait, I'm not completely showing the answer. This is just basically to see like just the differentiation and integration of power series. That's about it. Also for the pre-calc review, I'm not going to be uploading it because I gave up. Like, I just realized like I don't want to do it. Also, I have finals coming up. I have to study for Miss Chen. I have to study English. I have to study honors bio as well. So yeah, this is all I need to show it to you guys. It's basically learning. You can't really apply this anywhere, so see you guys later.